Hello, my amazing students. This is Mrs. A, and I love math. And today we're here talking about Lesson 97 in your Saxon Orange Book. We're talking about angles and triangles first, and then in Section B we'll talk about the Pythagorean Theorem, and in Section C we'll talk about Pythagorean Triples. We got by with a real short lesson. Last lesson, Lesson 96, was very short. It was about 8 minutes long. I think we're going to make up for it in this lesson. So, sorry about that. Here we have Part A, which is talking about angles and triangles. Now, the first thing they're starting out to do here is define what an angle is. So here we have two intersecting lines, L1 and L2, form four angles. So you can see angle A, angle B, angle C, and angle D. Okay, so that's pretty much two intersecting lines form four angles. Just about everybody agrees on that in the mathematical world. And then the definition of an angle sometimes gets changed up depending on where you are, but we're going to agree on this definition. So here was angle B, and we broke out angle B, and you can see that angle B is bounded by a half line and a half line. So the half line L1 and the half line L2 are also called rays. And we're going to agree upon this definition. An angle is formed by two half lines or rays that are in the same plane with a common endpoint. So the common endpoint would be right there at the corner where the two lines intersect. So we're going to go with this definition of an angle. So there it is. Okay, so here we continue with angles and triangles. If two intersecting lines are perpendicular to each other, the angles formed will be 90 degrees. We also call those right angles. So here I have a picture of what we're talking about. We have two perpendicular, I should make a little perpendicular right angle there. But if one of the angles is 90 degrees, then all of the angles are 90 degrees. And that's because the two lines are perpendicular to each other. Now, we also have a rule that the sum of the interior angles of every triangle, no matter what its shape, equals 180 degrees. So, let's look at some examples. This one, 30, 60, 90, 30 plus 60 plus 90 is 180 degrees. And then in this one, since all the sides are the same, all of the angles are also the same. We call that an equilateral triangle. And since all three of the angles have to add to 180 degrees, but they're all the same angle, then we divide the 180 by 3 and we get 60. So we know that all of those are 60 degree angles. 60, 60, 60. And in the last one, we have an obtuse triangle. And if we add 135 and 25 and 20 together, we also get 180 degrees. So, we're just showing that all three different types of triangles have 180 degrees. Every triangle, no matter what its shape, has 180 degrees in the sum of all of the interior angles. Now, this one's called obtuse. I just put it there so that you could maybe remember that. And this one is equilateral, but that's not really the point of today's lesson. Today's lesson, we're talking about this right triangle. Now, a right triangle has one 90 degree angle, and opposite the 190 degree angle is the hypotenuse. The hypotenuse will always be the longest side of a right triangle, and it's always opposite from the 90 degree angle. And the other two sides are called legs, and this is a right triangle. Now, right triangles have a very special property that we're about to talk about, and it's called the Pythagorean Theorem. So here we go. Let me show you that a little bit closer before I erase that board. So here, as we talk about that special theorem, or property, the Pythagorean Theorem. It's named after a guy named Pythagoras, and he's a very interesting character. He was the head of a very mysterious society, and he is attributed with this theorem right here. And he was in the ancient Greek. He was an ancient Greek philosopher. And here's his theorem. He said that the square drawn on the hypotenuse has the same area as these two side squares added together. So if we took a very famous right triangle, 3, 4, 5, and tried it, we know that if we have 5 on this side and 5 on that side, then the square is going to be 5 times 5, or 25. And if we have 4 on each side, 4 times 4 is 16. And if we have 3 on each side, 3 times 3 is 9. And 9 plus 16 is 25, isn't it? So that is how this cool Pythagorean theorem works. Now, more generally, we draw A, B, and C, because we don't always know that it's 3, 4, and 5. But we draw A, B, and C, and because this side on C, this square is going to be C squared in its area, and this one is going to be B squared in its area, and this other little leg is going to have a square that's A squared in its area. A squared plus B squared is C squared. Now, why do we care? What are we going to do with this cool Pythagorean theorem? Well, we can use this theorem to find the length of any side of this right triangle as long as 2 other sides are known. So it is very, very useful. And you're going to see how useful it is. Okay, so here we have 2 triangles. Now they look very similar, but they're not. This one has an A and a 4 and a 5, but the 5 is the hypotenuse. This one has a 4 and a 5 and a P, but the P is the hypotenuse and the 5 is a leg. So they're not the same problem, even though they have some of the same numbers. Okay, so on this one, we're going to say, well, the legs added together, so we're going to take A squared plus 4 squared must equal 5 squared. So leg squared plus other leg squared must equal hypotenuse squared. So now we have A squared plus 4 squared, so 4 squared is 16, equals 25. And minus 16 and minus 16, A squared equals 25 minus 16 is 9. So we have A squared is 9, or A is plus or minus the square root of 9, which is 3. Now let's check. 3 squared is going to give us 9, and negative 3 squared is going to give us 9. So now we get plus or minus 3. Does that side length look like it could be a minus 3? No, it's going to end up only being the positive 3. Okay, so we're going to only use the positive one because it's a side length of a triangle, and sides of triangles cannot be negative. So now let's look at this one. We have a leg and a leg and a hypotenuse. So we would say 4 squared plus 5 squared equals P squared. So now we're trying to find out what P is. So 4 squared is 16 plus 5 squared is 25 equals P squared. Well, when we add these together, we're going to get 41 is P squared. P is therefore going to be plus or minus the square root of 41. However, because we're talking about a side length, we are going to erase the negative. So positive square root of 41 is our P length. Okay, for our last two examples, we have here, we have a K that we're looking for. Now 5 is a leg, and square root of 61 is our hypotenuse. So we always have to make sure that our hypotenuse squared is on one side by itself. So we're going to say K squared plus 5 squared, the two legs, equals hypotenuse squared. So the square root of 61 squared is just going to be 61, isn't it? So we have 61, and then this is a 25, and then this is a K squared. So we're going to subtract the 25 and subtract the 25 from that side, K squared, and then subtract, we're going to get a 6. That's a 5 minus 2 is 3. K squared is 36. That means that K is plus or minus 6, but again, it's a side length, so we only accept the positive answer. And this side K is 6. And our last example under this part of the section is this one. We're trying to find M, which is our hypotenuse. Remember, the hypotenuse is always opposite the right angle. So we have an 8 and a 12, and those are our legs. So we're going to say 8 squared plus 12 squared is M squared. 8 squared is 64. 12 squared is 144. And those together will equal M squared. So when I add these two together, I get a 4 and a 4 is an 8. A 6 and a 4 is a 10. 208 is M squared. So we have to find the square root of 208. And I think we're going to do it this way. Yeah, we're going to do it this way. We're going to divide out, first of all, we're going to have square root of 208 is M, and it's going to be plus or minus, but we're only going to accept the positive one. However, there's something I can pull out of there to get it into a better form, and that's going to be a 4. So we're going to break this up into a 4, and if I divide 208 by a 4, I'm going to get a 52. Okay, and so the 4 and the 4 divided by the 52, and then I'm thinking that I can also divide the 52 again. So I'm going to end up with square root of 4, square root of 4 again, because 52 divides by 4, leaving a 13. So now this square root of 4 is a 2. This square root of 4 is a 2. Square root of 13. 2 times 2 is 4 square root of 13. So our answer for this one right here is 4 square root of 13. Now I could have gotten to that answer a little bit faster if instead of pulling out a 4 and then another 4, I had seen a 16 that I could have pulled out at the beginning, but I didn't see that. So I just pulled out a 4 twice and it worked. So here, before I cut it off, you can see the close-up of our Pythagorean theorem work. Now we're going to talk about some very handy numbers called Pythagorean triples. And Pythagorean triples are used so commonly that you really want to memorize them to help you in doing some really fast work with right triangles. So these are all right triangles. I forgot to draw the little right in there. But 3, 4, 5 we've already talked about. 5, 12, 13, and 8, 15, 17 are also Pythagorean triples. So you'll see these a lot because when books are just trying to introduce the concepts of Pythagorean theorem and write triangles to you, a lot of times they'll use these Pythagorean triple problems here. But cool thing is multiples of the Pythagorean triples will also work. So instead of just seeing 3, 4, 5, 3, 4, 5, you might see 6, 8, 10, because 6 is twice 3, and 8 is twice 4, and 10 is twice 5. Or you might see 9, 12, 15, which is 3, 4, 5 multiplied by 3. Okay, so let's just try it out. Let's take this one and double everything. So let's see if 10, 24, 26 works as a Pythagorean triple. So 10 squared plus 24 squared equals 26 squared. All we did is we took our known Pythagorean triple and we doubled everything. Okay, so a lot of times you'll see that in problems. They'll take one that you should know and they'll double all the sides. And if you're not watching, you'll work it instead of just know what the answer is. So 10 squared is 100. 24 times 24, 16, 8, 9, and then that's going to be a 48 right there. When I add that, I'm going to get a 6, 576. Now I'm going to multiply 26 by 26. 6 times 6 is 36. 12, 13, 14, 15. 26 times 2, 12, 52. 6, 7, 6, 6, 76. 100 plus 576 is 676, isn't it? Pythagorean triples are very, very handy to have in your back pocket. All right, here's our practice, our example. And we have 3 with missing numbers, 3 Pythagorean triples with missing numbers, missing side lengths. So the key thing is we know that 5, 12, 13 is a Pythagorean triple. We have to make sure the 13 is actually on the hypotenuse for us to be able to use it. It is, and so we will know that that one is 13. On this one, we have 8, 15, 17. 17 is the hypotenuse, and that's what it is. So the B must be 15 for it to fit, and it does. Now, on this one, you see C8, 10. That's not one of our known triples, but if we think of 3, 4, 5, and we multiply by 2, we would get 6, 8, 10, and 10 is used as the hypotenuse opposite the right angle. Therefore, C would be 6, and it's as easy as that. All right, here are practices A and B. Copy them down, and then do them by yourself before I do them for you. All right, so we first make sure that our right angle and our hypotenuse are what we're looking for. We're looking for the missing hypotenuse here. So we're going to say 5 squared plus 6 squared equals p squared will be our equation. So now 5 squared is 25. 6 squared is 36 equals p squared. 25 plus 36 is 61. Is p squared. Therefore, I need to take the square root of both sides. Our p is plus or minus the square root of 61, but it's a side length, therefore I will only use the positive. So p is the square root of 61. Here, our missing side is a leg, not the hypotenuse. So we have to write it correctly. 5 squared plus t squared is hypotenuse squared. Okay, so now we have 25 plus t squared equals 15 squared. 5 times 5 is 25. 75 and a 15, so that's going to be 225. We subtract the 25, subtract the 25 from this side, and we get t squared is 200. Okay, so now we have a square that we're going to take the square root of. So we know that t is the square root of 200. But we're not going to leave it like that. We know that 200 can be split up into the square root of 2 and the square root of 100. Well, the square root of 100 is 10. So that means that t is 10, the square root of 2. And those are your first two practices. Did you get them right? These last two we're supposed to use are Pythagorean triples. Okay, so we know that if we recognize this Pythagorean triple, it's a 5, 12, 13. 5 squared plus 12 squared equals 13 squared. That's 25 plus 144 is 169, and it works. Okay, so 5 and 4 is 9, 4 and 2 is 6, and the 1 from the 100. So here we should by now recognize that 3, 4, 5 is a Pythagorean triple, and 10 is a hypotenuse that's double 5, and 6 is a leg that's double 3. So wouldn't the 4 doubled give us the correct side? And we are done with that very, very long lesson 97, and I hope that you got all of your practices right and that you understand Pythagorean's theorem a little bit better and can now manipulate right triangles and find the missing side. This is Mrs. A, and may God bless your day.